So in this session, before you dive deep in the orchestration part, where you're going to see the BNF and the service orchestration, we want to explore a little bit, show you some system features that are very important for OSM to be deployed in a production environment. We have called it system features, and well, here we want to show the high availability, identity management, system quotas, and system monitoring. So first of all, let's start with the high availability. So what is high availability? High availability is about increasing the uptime of a service. So we are able to provide the service without any interruption for more time. And how does OSM wants to increase this uptime in our system? So we want to do it first using Kubernetes or Docker Swarm in the installation. So this will allow us to maintain the desired state of our applications, of OSM applications. So for instance, in the case of Kubernetes, if one pod fails, Kubernetes will take care of that. We'll see that has happened, and we'll create a new pod automatically. And what else? The other thing we are doing in OSM is the use of redundancy. So, for instance, in the next demo, we are going to show an installation that has three pods because it's going to be in Kubernetes and in different nodes. So there are many possibilities when it comes to install OSM. This means that it can be installed in many ways, and each one has their own handful options. So for this demo, we are going to show the charm installer that natively provides HA capabilities. Charm installer can be used just adding the --charm after the install OSM script. So, as I said before, its installation has their own benefits, and here are some of the benefits that charm installation provides. It is a production ready, so it comes with HA. You can do backups, upgrades of the applications. You can also do the lifecycle management of the OSM components. This means that we can change the configuration of a live OSM installation, do operations of the charms, scale one single component in case we see that is needed. For instance, we see that the monitoring charm needs to be scaled. We can do it. Also, the integration charms. Sorry, I think I messed with this presentation. Sorry about that. I will tell you anyway. Charms are integrated via relations, and this allows OSM to be integrated with external systems. And for instance, we can integrate OSM with an external LDAP. And finally, there is an ecosystem. So the OSM charms are part of a larger operator collection. This means that there are hundreds of charms. They are not just the OSM charms. You can find more. So here is the complete slide. Sorry about that. So this is what the infrastructure we are going to use for our HA installation. Here you can see that we are going to do an installation of OSM like it would be done in a production environment. So we will use an external Quotas cluster that is here, where all the OSM pods will be installed. We will use also an LXD cluster, where the proxy charms deployment will take place, and also a Juju cluster. So we will have our VCA, our component for operate the charms in HA. We have installed the Kubernetes cluster and LXD cluster in 3 VMs, and the Juju cluster is installed in a different 3 VMs. So we have used 6 different VMs for this installation. So now it's time for the demo. First, I want to explain a little bit what this tags means. First of all, we have the -- charm. This means that we are going to use the charm installer. We can, the next tag is the HA, -- HA. So we are going to use high availability for installation for charm installer. And next tags are related to what we show in the previous. Sorry, what we show here in the previous slide. So we are going to tell which is our Kubernetes cluster, which is our LXD cluster, and which is our Juju cluster. So here we are. These are the parameters for the LXD cluster. This is the VCA, the parameter for the Juju cluster, and Quotas is the kubectl for the Quotas cluster configuration. So let me change. If someone can.
Sorry, Guillermo, I think we may have. Oh, now your screen is showing.
Okay. So you can see my terminal.
Yes, we can see the terminal now.
Okay, perfect. So this is the command I use for the OSM charm installation. As you can see here, I use the -- charm, and I use the -- HA. And these are the other parameters I use to install OSM. So sorry about that, but I'm having some issues with my keyboard. First of all, we want to show you what is the status of the installation. I'm going to show you what is already installed, because this takes a lot of time, and we don't have that time to do the installation. So here in the user status, you can see that all the applications are installed and are active. And also, if we look, we can see that the applications have 3 nodes. and are all active and working. So this is with GGU status, we can check the status of our installation, and it's a very, very useful command. So next thing we can check is the pods in the K8s cluster. For that, we can do the following command, where we can see that all the installation, all the pods, we have 3 pods, and we have also an operator. That this operator it's in charge of deploying the application and also manage this application. So we have one operator for each application, as you can see. So a Kubernetes operator is an application-specific controller that extends the functionality of a Kubernetes API to create, configure, and manage instances of complex applications on behalf of a Kubernetes user. So this can be, this is the definition of a Kubernetes operator. So this week we are going to show how to create an operator using charms. This is something you will learn during this week too. So we can also check the status of the LXD cluster. For that, we can go to the LXD cluster node and check the status. As you can see, all is working and is online. And finally, we can check the state. We need to change our model. Sorry, I will need to change my keyboard. Okay. So we are going to change to the controller model. Now we will run again the GGU status. And we can see that our controller also is in HA. Okay, so our installation is up and running. We're going to play a little bit with it. First of all, we're going to delete one pod and check if Kubernetes is able to recreate it. We're going to delete this pod. It takes a little bit. And after it is deleted, we will check also the GGU status of our OSM installation. And we'll see what is the status after that. Looks like it is active. Let's check it in the here, and we see we have a new, a new pod up and running. So as Kubernetes took care of it, it is everything up and running. So now let's go into do an instantiation of a network service. For that, we need to first upload a BNF package. Don't worry about that if you don't understand something, because this is something you are going to do during the week a lot. So we're going to use OSM commands. So we have uploaded the BNF descriptor package. Now we're going to upload the network service descriptor package. And once this is done, we're going to create the network service. So this will instantiate the network service in the Vim. This will take a little bit. So meanwhile, I want to show you what is in this file, in the params YAML. Here we have configured that this network service will have two different, let's say, a charm that is deployed in HA, so with 2 units. So once this network service is deployed, we will check that one of the charms, the one that is in the BNF index 1, will have an HA proxy charm, proxy charm with two different units. So let's check the OSM receives already deployed. It is instantiating yet. We can check the models. This is the model. This is something also you will learn during the Hackfest, but this is the model that is created for the charm, for the proxy charm. So if we change to that model, we can check the status of it. As you can see, here we have 2 applications, 2 charms. And this one, the first one, has 2 units. So it is in HA. Another thing you should know is that the ones with the asterisks are the ones that are the leaders. So if one action, we create an action for this application, this is the one that is going to run the application. So we are going to remove that machine. So we will double check that the charm is still working. So this machine is being stopped, and now it will take a little bit until this one becomes the leader. Once this is the leader, we can run one action to check that this charm is working properly. So let's wait a little bit, because this takes a little bit of time. So meanwhile, you can check that the network service is still ready and working fine. There's no errors in the network service. Okay, so this one has become the leader. So we can run one action and check if the actions has been executed properly. Okay, so the action has been completed. So we can go inside the BNF with BNF member index 1 and check that the action has worked properly. So as you can see, we have created this file. That is what this charm is doing. It's just that's attached inside the BNF. So this is what I want to show you for the OSM in HA. Now let's continue with the identity management. So first of all, what is identity management? Identity management system provides access only to the resources needed to the right people. But this is important just to those resources. If you don't need to be a system admin, for instance, and you don't have that role, you won't be able to, for instance, create users or things like that. So it controls the access to the resource of the system. In OSM, we use a role-based access control called RBAC for this purpose. And right now, there are two different backends available. An internal one that is that handles this entity management locally, but the northbound interface, and also an external component that is Keystone that will handle these resources. Keystone is the default one for OSM. So what are roles? What are roles in the identity management? Those are the permissions that are provided, and the authorization is granted to an end user if it has the needed role to perform one action. There are different roles that are created by default by OSM, like the system admin that allows all the operation, account manager that allows administrative operations at user management and projects and roles, but it cannot onboard any packages or instantiate any network service. Project admin that allows all operations inside one specific project, and project user that allows onboarding and instantiation, but it doesn't allows the creations of beams or rims. Next, projects are organizational units. So this provides isolation. The user of one project cannot see or change what is done in a different project. So this is very important. By default, there is one project that is admin. And finally, users. The users needs a project and a role in that project in order to do something in OSM. And users, there is an admin user that is created by default in OSM that is assigned to admin project with system admin role. So in order to obtain privileges to do something in OSM, you should have a user belonging to a project and also with a specific role in this project. Okay, so now let's also start with the demo for entity management. So first thing we are going to do is to create a new user. We can, first of all, users we already have. We just have the admin user. So let's create a new one. Now if we show the users we have, we see the new created test user. Let's show more details of this user. That is done with the user show command. So you can see here that this user is not assigned to any project and is not assigned a role to it. So if we want to check what is in admin project with this user, for that we will export these environment variables. For instance, we want to check the VNF descriptor in the admin project. We will have an 401 unauthorized error because this user doesn't have this role in this project. So let's add this user to the admin project. For that, let's become again admin user. And let's update the test user we have. And you can see that we are going to include the admin project with system admin role. With the help command, you can see what is possible to be done with this command. So what we have done is set project that create and replace the role for this project. So we have add this role and project for this user. So now if we become again this user and we try to do the same command, the BNFD list, but we can see that we are able to execute this command. So next one, we're going to check the projects. We're going to create a new project. As you can see, this is quite, the commands are very easy to remember. For instance, for project create, to create a project is project create, to create a user is user create. So they're always like this. Let's solve this specific project. Okay. And now let's update the user with this project. So we will become a system admin for this test project for the test user. Okay, so now if we use this project, the test project, if we execute the OSM-BNFD list, we will see that now it's empty because we are in a different project. So as you can see, the projects provide us isolation. If we are in the test project, we won't be able what has happened in the admin project or in any other project. So next one, let's explain a little bit roles. For that, we will become admin again, and we will create a new role. So we have created a role called user role that will allow us to work with users, but nothing else. So we cannot work with the BNF descriptors or even with the roles. So now let's update our test user, and we are going to remove the project admin from this user. So let's check that the update is done properly. Right now, this test user only has this project, test project. We don't belong to the admin project anymore. And now what we are going to do is to add the admin project, but just with the user role for the test user. So now, if we try with the test user and admin project to check the BNFD list, as we have been done in all this demo, we see that we are not allowed to do it. The access is denied because this user right now only has a right to check the users in the admin project. In fact, we can the OSM user list. And we see that this command is allowed. Okay, so this is the demo for the identity management. Now let's move to quotas. System quotas. What are system quotas are? Well, system quotas were defined to solve a security risk. So they limit the resources that can be allocated. Let's explain this a little bit. Without this feature, you could, for instance, create an unlimited number of BNF descriptors in the system. So you can get your file system full with this BNF descriptors, or you can create an infinite number of network instance, and if the beam doesn't have a quota itself, you can also create an issue there where the beam is out of resources. So with this feature, what we do is we limit the number of resources that can be allocated for a project. This is important to know that this quota is applied to the projects. It's not applied to the user. So there is a default quota that is 500 that is applied to all resources. And this quota applies to all the items managed by the projects. So it's everything except with the users, projects, and roles. So all packages, BNFDs, NSDs, network slices, templates, the instances, the infrastructure, so the Beam accounts or SDNs, controllers, the PDUs, the repos. All these can be limited by this feature. So let's start with the next demo. For this, the first thing is to become admin. And now we are going to create a new project that we are going to call it Project Quotas. And we are going to create it with these limits. Beam account, it's 0. NSDs is 1. And instances is 1. So if we do a project show quotas, we see here that we have these limits. So this is a big issue because we cannot create any Beam account. Let's try and see if this works. Sorry for that. First, we need to have a user in this project with enough rights, with a role that allow us to do all these operations. So we are going to use our test user, and we are going to add it to the project Quotas as system admin. So now we become test user. And let's try to create a new Vim account. As you can see, we see the error here that we have a quota of 0, and we have exceeded this quota. So we are not able to create a new Vim account. So let's try to change this quota. As you can see, we have changed the Vim account to 2, and this NSD equals, and with a no value, this means that we are not going to set any limit for this, and neither for NS instances. So now we have only the Vim account to 2 as the only limit we have for this project. So let's try it again. So now we have this new Vim account. Let's create a new one. Okay, our limit was in 2, so this is fine. So let's try to create finally a new one. As we can see, we have exceeded our limit that was in 2, so we cannot create a new Vim account. Okay, so I think this is all on my side. Now I'm going to pass it to Gianpietro, that I think is going to present the OSM monitoring system.
Thanks, Guillermo. Good day to everyone. I am sharing my screen in a minute. Guillermo, can you pass me the privileges, please?
Not sure how can I do it.
Pietro, I don't see you in the list. What is the name you use?
Maybe you are as Hackfest, Gianpietro?
Yes, I was as Etsy, sorry. Now I changed my name.
Okay, I think I made you presenter.
Wait, thanks. Okay. Can you see my screen now?
Yes.
Great, thanks. Okay, the last part of this section is to show you how do we do system monitoring. Well, this is one. So today, the most comprehensive way of monitoring the system, of monitoring the host that includes OSM and also the containers and some of the key components of open source Mano is through the Kubernetes installation. So when you install OSM with K8s, you have the opportunity to include this knob, which is K8s monitor. You can do this, or if you already have an existing installation and you want to add this K8s monitor, you can use the O option. I'll update the slides later, but it's also in the user guide. And add the K8s monitor. This is a new namespace that would be in addition to the OSM namespace, and would let you see already pre-created dashboards that monitor the system. So it's including some health monitoring for Kubernetes and some monitoring for the components of OSM, and also the resources that OSM consumes. So when you install this K8s monitoring, what you are doing is adding some Prometheus operator and exporters. This is the name of the tools that are installed. Exporters are a way of Prometheus to collect metrics. So you will have exporters for different kinds of components that OSM has. You will have exporter for the node itself, which if it's a VM or if it's a bare metal server, it doesn't matter. You would monitor the resources of the node that contains OSM. So you would have these pieces of software in containers that run in a special namespace named monitoring. And what you are monitoring is the Kubernetes core components, the OSM pods, and the host itself. What you will see is a set of dashboards, as I mentioned, like this. But it's a long list of dashboards that are included. So you will have really a comprehensive monitoring system for OSM. So now I will go to Grafana. Only one of the, well, in this opportunity, we have 2 machines for OSM, and we have installed the monitoring one of them so that you can take a look. But this is only for demo purposes. The idea is just for this session to be not to be hands-on, just a demonstration on how you can monitor the system with the K8s installation. So when you create an OSM, in this case we have a lot of tenants, but you will see, in addition to the dashboards that are created automatically by Mon, you have these 2 tabs here: Kubernetes cluster and open source Mano. If you open the Kubernetes cluster tab, you will see here a lot of dashboards already created. For example, you can monitor this Kubernetes compute resources cluster, and it will show you how Kubernetes is using the resources of the host. You can see, for example, that the OSM namespace has 13 pods, OpenEBS has 7 pods, the monitoring system itself has 8 pods, Kube system 5 pods, and there is a controller this is installed by UU, is 1 pod. And the memory that is consumed in total by each namespace. So you can see that OSM is taking most of the memory of this host. If we go back, we will see just a list of the Kubernetes dashboards. And you can see, for example, per pod, how each pod is consuming the resources. And you can select here each pod, and it will change to the core Kubernetes system pods. Then you can change, for example, namespace. I can put here OSM and see how Grafana is taking resources, see how Mon is taking resources, whatever you want to monitor, you can select it here. And finally, what else can we see? For example, the nodes of Kubernetes. In this case, we have just one node, but if this was a multi-node installation, for example, then we will be able to select the different nodes that compose this installation. But in this case, we are just having one node, and we can monitor CPU, load, memory, and everything. Networking, for example, for each particular interface, virtual interface that is in this node. Then we have, if we go back to dashboards, we have another tab which is called Open Source Manu. And there we have just a limited set of pods, or well, of dashboards. For example, let's see the hosts dashboard. We can see some statistics for the host of OSM, CPU, disk, memory, and network in particular. Very summarized. Then we can see, for example, more dedicated dashboards. For example, the health of Kafka. The Kafka, as you know, Kafka is one of the components of OSM. It's the message broker for the different components for their internal communications. You can see the messages per topic. We have a topic, for example, named alarm response, PLA, SDN, WIM account. And we can see which are the messages that the topics that exchange more messages. Right now is the admin topic. Then we have in the sorry, I will go back here, open source man. We can monitor also Mongo database, the uptime, the connections it has, the queries it has executed, the type of queries, the memory is consuming. We also have it for MySQL database, how many instances, the uptime, the connections. So as you can see, it's very detailed. If you go back here, finally, there is an OSM status summary. And you can see statistics about the specific pods of OSM. We have 38 pods running in total. But for OSM, we have these ones. And we can see that one of them is down, actually. That is because we have just changed the UI. The previous UI was called Light UI. And in this Hackfest, we are using the new UI, which we call next generation UI. So it's not automated. I mean, we have not changed the name yet in these dashboards, but it's just as simple as editing these settings for the dashboard, putting the name of the deployment, NGUI, for example. We can also change the name and put NGUI. And then if we go back, we will see that the next generation UI is up as a pod. Of course, the light UI was not included in this installation. So now for that, we have a knob and installer, which is using the N letter, -N, and you select the next generation UI if you want to install with the new UI. But that you will see in a specific session. Okay, so here we can see the CPU usage per pod in a single view, which is very useful. Also the memory usage and the status of the pods in general and the system itself. So this is, I would say, the most summarized dashboard to see the health in general of the OSM system. Okay, so now I will switch to my terminal, just a second. Have a question there. Does Prometheus also monitor UU and LXT cluster? Not right now. We don't have an exporter installed for that yet. This, I would say, is work in progress because we have different ways of monitoring OSM that we are testing. In the K8s installation, we have this alternative. In the Docker Swarm installation, we have another alternative for monitoring the system, which is just with, I would say, a more simplified one, just uses the C advisor and the node exporters from Prometheus. And then in the Charm installation, I'm not sure if we have included a monitoring stack yet, because it's the most recent one. Maybe Guillermo can comment on that. Are you there, Guillermo?
Can you hear me?
Yes.
Okay. So can you repeat? Sorry, Gianpietro.
Yes. It's just I would like to clarify. I was clarifying which methods of monitoring the OSM system we have today in the different installations. I was saying that the K8s monitoring is maybe the most comprehensive one right now in the community. Then you have in Docker Swarm installation, you have simplified monitoring included with a couple of exporters. But I was saying that the Charm installation was the most recent, and I'm not sure if it includes a monitoring stack yet.
No, it doesn't include this monitoring stack yet. It's a work in progress now.
Okay, thank you. So I will share my terminal just to show you how this looks like in the terminal. Okay, here we are. Okay, this is the machine that includes this installation of the K8s monitoring system. So if we get all the pods, for example, all the namespaces, you can see here this monitoring namespace. And you can see it includes an alert manager, a Kafka exporter, MongoDB exporter, and some other pods that let us monitor the system itself. So this would be in addition to OSM. It's a separate namespace, but it does share one component, which is Grafana. So the same Grafana pod that we are using in OSM, it's used for integrating to the Prometheus that is running in this monitoring system. So now I'm gonna share with you some other settings in Grafana. So if you can see here in configuration, data sources, you will see that there are two Prometheus instances. One is the Prometheus database that holds all the metrics of OSM, or from the DNFs, from the projects, things that are for the end users of OSM, let's say. The Prometheus that comes by default in every OSM installation. The Docker Swarm based, the Charm based, every OSM installation includes this Prometheus with all the metrics of the VNFs and what we want to do with our network services. However, in the case installation, you have this other Prometheus that has connection to all these exporters that can monitor the system. So this is a separate pod and it's connected through a separate URL. And it is configured automatically in the Grafana of OSM when this namespace exists. Okay, so this is what I wanted to show you regarding the system monitoring. Do you have any question? I'm checking the Hackfest's channel also, so no questions. Maybe we can explore a little bit the spreadsheet, because after lunch we will start preparing our environment, and you will have to start connecting to your own OSM environment. So I will present the spreadsheet and let you know how we are going to organize this time, and then we can continue for lunch. Can you see it? Yes, you can. Well, this is the way we are going to organize this time. Again, as every Hackfest, we are trying to monitor the progress through this spreadsheet. It's easier in this remote format. So we have an amount of tenants, and the different tenants are split into OSM instances. So the first half of the participants will be working with an instance, and the second half with another instance. But this time there is a sort of innovation. We have an intermediate machine that is the same for everybody, and will let you connect to the different OSM instances. Then I will be sharing this now, so you can start putting your name in different tenants that you want. So I'll put here in the Hackfest Slack channel. Resources spreadsheet. You can start accessing now and allocate and put your name and email in one of the tenants, please. So then we can also figure out if we have enough tenants, and during the break we can maybe create more if we're just missing a few. So in column C, you will put your name. Column D, you will put your email, and that's it for one tenant. And then I'm going to explain how to connect to the different systems. You don't have edit access. Oh, okay. Let me change that. Okay, you can edit now. If you refresh the spreadsheet, you will be able to edit. Please just modify columns C and D. Oh, yes. So for connecting to this management VM that you will be using throughout the week, you need to connect first to the VPN. So make sure that you have a VPN account for connecting to Hive VPN of Etsy. If you have credentials already but it's not working for you, please contact Gianluca. You would either need a VPN a site-to-site or a client-to-site VPN. Someone is asking, I think at the general channel of Slack, we have a Hackfest channel. I will send you the link in there. Oh, thanks, Sylvia. Okay, it seems we have enough tenants, unless not everybody has updated the spreadsheet yet. Please make sure you put your name in there. And as soon as you are ready, I will give a brief overview of what we are doing after lunch. Okay, it seems we are ready. We have 35 participants that will connect to tenants. Open the spreadsheet, the presentation, running in our environment. Okay, just a brief overview of what we are doing after lunch. We will connect to a management VM using the user and password that corresponds to our tenant. We'll see more details later. But that is automatically connecting you to a home folder where you will have already the credentials for OpenStack, for OSM, and for Kubernetes in there. So with this single machine, you will be able to access the different systems. Okay, but we will see the details after lunch. One important thing that I want to highlight is that whenever you access Grafana throughout the week, you will be offered an option to change the password. Since we are sharing the same Grafana instance, please do not change the password because it will bring problems to us, especially today that we are seeing some monitoring of DNFs in the system. Okay, so please remember not to change any password in Grafana when you access today. Okay, thank you for populating your information. Any question before we go to the break? I'll switch to the GoToMeeting.